che va bene. Invece dopo ho fatto, ok, prossimo catturamento, continua a rimanere su energy, su process, però...
So, welcome everybody. Today, we have a special day. We will visit our colleagues of Atlas, and at the workshop where they build huge detector elements. There we will meet our dear colleague, Atlas physicist and president of this Physical Society of Switzerland, Hans-Peter Beck. And afterwards, we will visit this side here on the Atlas side, where you have the graffiti at the back side and IDEASquare. But to start with, today I'm not with my bike because it's too far. I will go with my car because we're on CERN point 1 and we have to and their main side is also more than a kilometer at the Atlas muon wheels. We get out now of CERN point 1, the Atlas side. Sorry. There are interesting animals you may see here. This is an interdisciplinary collaboration with farmers. Of the accelerator. Right.
Michael, you're muted.
Michael, we can't hear anything. Michael, are you trying to get the sound on? Can you nod? Are you trying to get the sound up?
So, hello, can you hear me?
Yay!
Oh, cool, I get a sign of life. Good. Sorry, there seems to be some technical issues up to now. So as you can hear me now, you can see me and Michi in a construction area where still elements of the Atlas experiments are being constructed. And now you may scratch your head and say, why is the construction work going on? Atlas is existing. But there are upgrades, and I can show you the upgrades that are being done. And those are first manufactured in a construction hall here at CERN. And Mick is now changing the screen. Yes, please take it. Du hast die Finger jetzt davor. Halt das mal. Wo ist die Kamera? Da. Da ist die Kamera. Okay. So we are here in a construction area, construction hall at CERN, where elements for the Atlas detector are being done. And you see here this triangular shape with some brass color or some copper color. These are segments for the new small wheel. It's a muon detector. And with those, we want to measure muons. So I hope you know what muons are. Have you heard about muons before? I don't know. if you have
Yes.
Okay, good. I don't need to explain what are muons. These are just the heavy brothers of electrons. You see here where Mich is standing. So this gives you a view of the size of the whole thing. And any of these segments, they just are elements, and you bring them together and you form a wheel. So obviously these are too few elements to get full around. So this gives you an idea about this muon wheel that we are constructing here, with all these individual elements being up, and you see numbers of cablings. And then this wheel, this is an end cap of the Atlas. Atlas is as an experiment, looks like a barrel, like a Coca-Cola tin can with end caps. And this muon wheel will be one of the end caps, but not for the full Atlas. Atlas is much bigger than this wheel would make up. So we call this the small wheel. It's a small muon wheel. But if you put Mich aside, you see how little Mich is, or what we think about what a small wheel looks like. So just take all these segments and build them all around in your imagination. And build, so the far end is surrounding the beam pipe where the protons are getting into collision, and the outer end, the big end here, is just where the small wheel will end. You see here cabling and electronics, and gives you some kind of an impression. You see here plastic rubber pipes. This is for some gas. These detectors obviously need gas. They need high voltage, they need readout, they need detector control, they need settings, and muons will simply squash through these elements and trigger signals that are important for Atlas to reconstruct the full event. So now we are walking further through the hall. In front of me, you see Atlas again, but what you see is basically empty. You see a big hole and some iron structure around it. And when you look further up, you see some yellow and bluish construction. All this is not real Atlas. All this is a mock-up. It's a full-size mock-up, in order that the engineers and the technicians, when they put in the real elements, when they have to slide in detect elements, they can try and see where will be problems, where are problems to be expected once they have to do it in the real size. So this mock-up is standing here now since more than 20 years, because it has been important when a real Atlas needed to be built and constructed. But it's still here, and it's still being used when we have modification or upgrades that we want to do. We use the mock-ups to try it out. Okay, let's walk. Let's see where Michi is going. We follow Michi. So we follow here through the halls. You see at CERN there's lots like an industry, construction grounds. People are working on all kinds of technical elements. And now some magic door is opening, and oh, when we go through the door, what we will see, that's perfect. Now we can see how this individual element seen before made up to be a full small wheel. So just look around. Just look around what you see now, all these individual elements, and you see people. Can we zoom that up? You can see here people working on the construction on this small wheel. You see here is a cherry picker. This red thing is a cherry picker crane, and in the cabin on top there are two people. There's one person working up there, making sure all the cabling is correct, doing some tests, making sure that whatever connector is in has the right polarity, that no connector is left out, that all the electronics is being done correctly, that all the gas pipes are being done, that all the cooling is done properly. And before, here you see another person working on another segment, doing the cabling efforts, the cabling work, testing each individual wire, whether making up the connectors one by one, And you can see it's a tremendous work to get every single segment of these wheels being done and constructed. This is just assembly now, because the construction effort of every single wheel has been done prior, but it needs to be assembled. And the assembly is what you see. And you see not just one of these wheels, you see a second wheel. And you see in this second wheel, only the lower half of the segments have been installed. And you see the blue spots where more segments will be added. These will be filled, these blue spots, with those segments that you have been seeing before. So this thing here, and those segments that I've been looking at during my introduction, they will all find their space up in this, where the blue structures are, in this blue wheel. So Mickey is guiding me, he's telling me we have to walk around. There's more to see. And you're very lucky that you can see such a construction going on. It's one of the big upgrades that are going on. And of course, we are not inside the ATLAS experiment, because once everything is put together, it will be transported as one single piece across, out of this big hall, across the roads, not far from here, down to the ATLAS pit, and will be lowered 100 meters below ground to find its final destination. And this is really, really impressive. I haven't seen this myself. Also, I'm working on ATLAS since more than 20 years. I haven't been that close to this specific part of the construction. And this gives you a sheer impression of what's going on, of the complexity. And this is just one of the subdetectors in ATLAS, and ATLAS has many, many subdetectors. And you see every single one has a tremendous amount of complexity involved in it. So we're following Mickey further. Can you still hear me? Please give me a sign. Can you still hear me?
Yeah.
Okay, good, perfect. And you can see the pictures. You can see what I'm showing you. Are you impressed? Are you impressed?
Yes.
Yeah. Good. Let's walk further around.
Here is the installation tool.
So yes, what you see here, these are just installation tooling. This is a support and scaffolding structure, because all the big wheel has to be transported. So it will go onto this transport structure and will then go on a big lorry, that it can be moved in one single piece. And you see now the cabin of the cherry picker just lowering, where the head is of the person next to it. You see this silvery shiny thing. This is where the protons will go through of the LHC. So this will be just at the center of the LHC accelerator, and it will be part of the beam pipe, where the protons will go in and out in both directions.
Okay, so I think let's walk back, and let's the villain of the stairs from ATLAS side.
Okay.
Who does study the next.
All right. So what Michi is now guiding me to, he's telling me where ATLAS is, but obviously I do know where ATLAS is. I know it's more than 20 years, but I still follow Michi, so you know how the thing looks like. And we will drive over to ATLAS. This is the same path that these muon wheels will also do. Oh yeah, here are more segments. Here are more of these segments waiting for being installed. And you see here some sandwich structures. So there are these two planes next to each other. So the muon will go through like this and make signals in both of these planes. And then we can reconstruct muon segment tracks. And then we can sandwich more and reconstruct the muons that will go through these structures and give the signals that we need.
It's a sandwich of 4, but 2 different
yes. Yeah, if you look here, it's precisely, you see, this is a sandwich of 4 layers. The outer layers are a different technology to measure muons than the inner layers. And there's a very specific reason for that. because the outer layers, they give very fast signals. And with those, we can have a fast decision. Yes, there was a muon going through. And the inner layers, they are there to make precision measurements.
May I ask you where you come from? I'm from Portugal. You're from Portugal. Maybe
Yes.
you speak in here.
Yes.
Just
Yes.
can you explain us where you come from and what you're doing here?
Yes. So I'm from Portugal originally, but I did my PhD at Weizmann in Israel, and so I'm working on the new small wheel upgrade project, and I'm one of the integration responsibles in building 180. So from the STGC part, so we get the STGC chambers, which are wire chambers, from the construction sites all over the world. So China, Russia, Canada, Israel, and China. And we get them here at CERN, and we basically integrate them into bigger detectors. So also we test, and yeah, we do all the electronic testing and everything. So we do the commissioning on on site. Yeah. So okay.
What was your name?
Artur.
Adu.
It's like Arthur without the H. Yeah, without the H.
Artur.
Okay. Yes.
Okay.
Yes. Okay.
Thank you. Thanks a
Bye.
lot.
No problem.
And all the best for your continuation.
Thank you. Thank you.
These people, they are the huge stress because the timing is very, very tight for the scheduling, because it's not just that this small wheel needs to be installed. There's plenty of installation that have to be plugged in one by one. And if one is late, then everything can be late, and this can get a huge problem because many components have to work simultaneously together. By the way, if you have listened to Arthur carefully, you have heard that he's working together with Russian, with Chinese, with Israel, he's Portuguese, all this, and we have the US participating, and the whole world. What we get here is a place where the whole world can work together. So politics, in a way, does not play a big role, because there are bigger things to talk about. We talk about the universe, we talk about the electronics, we talk about the detector and the data. So talk politics, in a way, is a bit vain, a bit nitty-gritty little things.
One thing, please tell them that we go now by car, and
Yes.
the connection may be lost.
Okay,
But
good.
as soon as we're back online, we'll be back.
All right. So to repeat what Michi just told me, he will now take his private car and drive over to the Atlas pit. So and I will try to continue entertaining you and talking, but while in the car, connection may be bad, but don't worry. The car drive is just a few minutes. Just hang on, and don't worry. We cannot guarantee that while driving Zoom or Teams, whatever this is now here, will do its job properly. Now we get to Michi's car. This
Alors finalement non.
buckle up. I hope everything is fine for you. Just take the road. should work. I think it works. I hope it works. So the fire brigade, you see here that we are just crossing by the fire brigade. This is the fire brigade building. And crossing before end. You see we have nice weather. We have medical services in this building. It's all a huge industrial area when you're at CERN. Every CERN is a huge industrial. All there for research, the basic fundamental research. Now what we're doing here is this is just getting out. This is the barrier. We have to wait as it closes and it reopens front. Has been a camera landmark, which makes it recognizable. And district goes down, lead us to the city of Geneva, which is not far in that. Well, their president is on our. Oh yes, your president is today here in Geneva. You may have heard about. Discussion. Bonjour. Merci bien. Merci. Non, c'est pas mal. Bonne soirée. Bonne soirée. L'université de Tallahassee. So all the barriers for the guard is passed, and already now we are on the Atlas side. You see, Atlas is very easy reachable, just a few minutes, and you can find some parking space.
Hello.
Hello.
Hello. Okay, good. You can hear me. That's perfect. Okay, now we're just outside the Atlas experiment. So the Atlas experiment, what you see here is some graffiti painted on a wall of the building in which the Atlas control room, the control center is in, and technical coordination is located. You see these reddish boxes in front, and you see Michi now walking closer. He has parked his car. So these red boxes, these are just power distribution stations. Every one does something like 2 megawatts, and there are a few more here standing and here standing. What you can see, an experiment like Atlas needs many megawatts to operate. And when we go inside that building, we don't see Atlas because we are on top of Atlas. Atlas is 100 meters below our feet. So below where Michi is standing, a bit further behind, the LHC accelerator is just passing by 100 meters below our feet. And below, and at that place also we have the Atlas experiments constructed, obviously. And you see here the mock-up, the graffiti painting, where you see the collision in the center. You see these white splashes getting out of the collision point, and you see muon lines that go up at 11 o'clock and almost 12 o'clock. This gives 2 muons. You see next to the 2 muons in the greenish layer, you see some reddish structures going up also at 11 o'clock and 1 o'clock. And this is how electrons look like. And next to it, you see the size of Michi. And no, the wheel we have seen is not what Michi is pointing at. The wheel we have seen before
is this blue this structure. Next to the yellow structure, left to it, you see some blue segments that take around. So this is the small wheel. This is a small muon wheel. This is what we have seen before in real. That's how it will be constructed. And the reddish structure here is the big wheel. This we haven't seen. You just see here the construction. But I have to disappoint you, because the wall that you see here is way too small to cover up real size atlas. So you have to imagine everything twice as big as being drawn here. So we walk further through a fenced door and get into, and this way we get closer to the Atlas control room. You see 2 more people walking across me, and we're getting in up this few stairs. This is usually the Atlas visitor centers. It's being hello. This is the Atlas visitor, which is being remodeled. So you don't see much in here, but you see here people working on putting up new
No, it's frozen, Stephanie.
Hello, somehow the network had an issue. Are you back? Can you hear us? Can you see us?
We can.
Okay, excellent. Sorry for all these hiccups. We don't know. So now we are in front. We are just here at the Atlas control room, and what you see here is plenty of stations where people can sit and have their individual screens to control and operate individual elements of the Atlas detector, sub-detector elements. So the desk for the muon detector, other desk for the colorimeters, other desk for the magnet system, other desk for the overall control, other desk for the safety, for the data taking, for the liquid argon colorimeter, for the hadronic colorimeter, for the forward, for the end cap, etc., etc. So plenty of stations, but what you also see, they're all empty. And you may ask, why are they all empty? The reason is not COVID. For once, COVID is not the reason. The reason is we are in construction phase. There's no data being taken. There's nothing specifically going on. There is work to prepare the muon small wheel being installed. And for that reason, only a minimum occupation of people is around here. Mainly those who have something very specific to do with new elements being added. And of course, some people who are responsible for the overall safety. That's how it looks like. And it just
Now we go over to the IDEASquare.
Okay.
It's on the same
So
side.
and the room we are in here, this will be a new visitor center for people who will visit Atlas once it will be rerunning.
If they come in December, they will.
So if you ask, Mickey said, if you come in December, then you can see it in real. So now we do not need to take a car. So Mickey is guiding us through. See again the globe of innovation behind. You see some. You may see also screens. There's some power lines. CERN needs a lot of power, so there's also power lines coming in and out to CERN. And if you look further, you may see the Alps rising behind. You may see the snow-tipped mountain in the far end. I'm not sure you can see that. But if you can see it, this snow-tipped mountain is called Mont Blanc, the White Mountain. And it's the highest point in Europe. That is fully inside Europe. It's almost 5,000 meters high. Its highest tip, 4,857 or so. And we have on this side, we have the Jura Mountains. There's plenty of things to do. If you like skiing, if you like landscape and sceneries, it's a good place to be, it's a good place to live. And here we are already, so this is now in front of IDEASquare. So Michi is pointing up to the IDEASquare. Think, do, collaborate. That's the motto of this place where we are here. So at IDEASquare, we not just have the physicists working, we also have people. So people that are fresh out of university or have only a little bit of experience after universities, and there are physicists, there are engineers, there are artists. For IDEASquare organized a London double-decker bus, just that you get into a good mood, get inspired in your way you think and what you do, and help you to do the brainstorming. A place that you need if you want to do good things. If you have to be very creative, then you need a creative environment. So now give back to Michi the talk to you.
Yeah. Hello, hello.
Hello.
Hello, yes, I hear you again. So let me show for it. So first of all, I want to thank Hans-Peter for the tour in Atlas. And now I'd like to, oops, the tour in Atlas. And now I would like to show you a little bit the IDEASquare, which is on the same CERN site.
Tallahassee just fall down.
Hello. So
Hello.
upside down. Oops. So this place is a special place because they do the similar thing what we do with science and art. They do with science and technology, different science. So they collaborate with, it's a cross-disciplinary program here, inviting different engineers, technicians, and creative people working on scientific and technological innovations to be afterwards implemented either in at CERN or elsewhere. So it's not CERN here. This is a project on its own, but CERN is hosting it, and it's since several years, and it's very modular structured. So the color code of these boxes are somehow representing the functionality of the people sitting in there. We have different boxes. The white boxes are the permanent boxes or the office boxes of projects. Green is the common meeting room, and as well as the double-decker bus, you have two meeting rooms, one at the lower floor and one on the upper floor. All are equipped with screens and communication tools. And then you have also the first floor. We go up here with some offices for colleagues, or there's a workshop, a 3D printing workshop. So we have various 3D printers for prototyping. So projects then common meeting areas just to discuss or relax. Here, the view. This is here, back there you have a lot of chairs. This is which is put up here for big auditorium if we need it with a big screen. And another important specialty is here. Well, then you have here electronic workshop. And machine workshop. And printing and cutting. Yes. And another important meeting room is this here, because this is the kitchen with the coffee machine. So and this is a place where we now stop for our today's tour, because this is the most one of the most important places here, most communicative places here with the coffee machine. And they even programmed the coffee machine such that it takes longer to boil the coffee, that people stay longer together to have a creative discussion. So
That's really fun.
so if you have any questions, if you please come up now. As long as Hans-Peter and me are still available, so you can ask Hans-Peter for any Atlas question, and if I can answer about IDEASquare or the idea of the IDEASquare, I'm ready to answer.
Looks like Mackenzie has a question.
Yes,
yeah,
please.
I have a question about the colors.
Wait, one moment. Talk again, please.
Okay, I have a question about the colors. You said in the IDEASquare they're color coordinated for a reason, but on the actual machines, like the Atlas machine, are the colors there for a reason, or are they just like a random design?
Well, I can talk for CMS. CMS has a color code, and that's why it's very colorful and very this adds also to the impression and the aesthetic of CMS. And there in CMS, as we discussed, when you have been visited CMS, it's linked to a certain facility functionality of the size. So as here they have the color code also for the functionality of the different boxes, because the boxes are all the same. They are standard construction boxes, but they colored it differently and set it up from the architecture like this to signify so what kind of how to use it. So, and if it's empty, you can then book any meeting room, any common room, but you cannot book the private offices, of course, of people who are in long-term projects. For Atlas, I give the word to Hans-Peter.
Absolutely. So obviously Atlas also has its color code, and it's also very aesthetically. If you look from outside Atlas and CMS, then you will realize CMS is more orange and reddish, whereas Atlas is more bluish. So there's no overall color code, color scheme, but every collaboration has its own taste and own way of using colors to signify specific elements of the detector and the meanings and Atlas is obviously, as I'm an Atlas physicist, I'm very biased, so it's much more beautiful, of course. It's bluish, but I will let Michi dispute that view.
I don't dispute on aesthetics. This is everybody's own taste.
Everybody's taste. Absolutely.
There's Atlas has one Atlas blue, so they have a specific blue they use everywhere for blue. So. And in CMS, there's no specific color. It's dominated by red because all the iron is made of red. Then you have silver, the same silver like in Atlas, because this is just pure metal, aluminum or stainless steel. So the big chambers, or you have orange. So what you have seen also today was the Atlas muon chambers. They look orange, like a little bit orange or golden, if you like, because this is pure copper surface. So you have, and some surfaces are painted, and then you of course the cables. So in CMS you have different cables with different colors, and in Atlas you have one color cable. The most of the cables are blue again. So they are.
This depends. High voltage cables are more red. Fiber cables are more yellowish. There's fiber optics in it, and we have low voltage cables. They are less. They have all kind of colors, but high voltage being red is important. So if you have a wire with 4,000 volts on it, you better know before what you're doing.
Thank you.
When is your deadline then? So you're under construction. When does it have to be ready by?
Well, the whole accelerator now is in what we call long shutdown 2. And long shutdown 2, well, obviously this followed long shutdown 1, which was a few years back. What we regularly do is we upgrade the accelerator, that it has higher energy and
higher collision rates. So the number of collisions per second, number of proton collisions per second, we need to upgrade. And when we do have higher energies, when we do have higher collision rates, the electronics of the detectors need to follow, need to be upgraded as well. And certain detector elements that can be changed will be changed in order to cope with much bigger rates. And these are typically endeavors, they take, they're scheduled for a year, but sometimes they take 2 years. And when because the schedule is always tight, and COVID, of course, had a big impact on all our planning, we will likely further delay the restart of everything, because plenty of advances have been made with all this upgrade works. And there are huge discussion going on because a few upgrades will not make the deadline. And
So are you starting new upgrades now for the next time you have the shutdown?
Oh, absolutely, absolutely.
Okay.
If you have to construct some inner detector for Atlas or for CMS, which is a football field of silicon devices that need to be plugged together, this has years and years of planning, of R&D, research and development, of trying out, and of programming, and of electronics, and of getting the thing ordered and assembled and tested and tried out. So that's a huge task involving many institutes collaborating across the globe.
Okay. So in the design, in the idea space that you're in now, do people go there to rethink a piece of mechanics or a piece of technology for future, or is it just like a kind of free for all? Let's just invent anything we can.
Yes. So IDEASquare, as I said, is not CERN. It's
Okay.
It's at CERN because it was founded by a member of Atlas collaboration, and they just placed it at the Atlas site. And
Okay.
of course, using the CERN infrastructure, and also, but what IDEASquare is doing is unique in its idea. As I said, it does the same thing what we try to do with science and art. They do with science and technology, and it's not just particle physics driven projects. There are environmental projects. You can apply, and then they assign you some. You can use it as an infrastructure, as we have foreseen to use it for our project, coming here for a week and using the infrastructure, the workshops, but mostly the site to work for you, and also to come together and have a host while we are here. So it's completely diverse. And this is the beauty of the exceptional of this exceptional installation.
It's a place to be creative about science and technology, and come up with new ideas that would not emerge in another environment. Because we bring here young people from various backgrounds, from various geographical areas, and they should find inspiration while being here. And they're completely free to invent whatever they like. But everyone, in a way, is also eager that something gets done, something comes out of it. So they have brainstorming, they have fun events together, and then they post themselves some project they would like to advance on.
Right.
So any further questions?
Maybe you know of something that came out of it. I'm not in touch with ideas.
Yeah, there are several. I mean, last time I spoke with the organizer here. They have a very interesting program and project here with Italy for environmental. So they had they designed and tested and then implemented technology to test in the supermarket how fresh are vegetables and fruits. as a quality insurance, that you do not throw away stuff which is still good, but you just sort out when, if it starts to be deteriorated. And this worked out fine, and they several supermarkets implemented this. So I think, and this is this type of things where you try to, it's a purely interdisciplinary mix of specialists. You get to they get together, and then products. It's about having ideas and then trying to get the test phase. And before the implementation.
And you also see testing the quality of fruits and veggies has nothing to do with what CERN is doing about. The idea here is we bring in a few creative people and they have a creative idea and they're free to develop whatever they think may be useful for the world.
But however, even if it's not fruits, which is the main core business of CERN, but the detector and the sensors we are using here and implementing here may be used for different things as well. And this is the idea, to bring together creative people from outside, connect them to people at CERN, to specialists in their field, and see what kind of ideas can come up and what kind of products may arise by just a pure dialogue and the cooperation. Collaboration, as we have seen at the entrance. Do, think, and collaborate.
Okay, sounds good.
And by the way, maybe I have to see, so there are also from time to time an artist for a longer period here. So this is another branch. But this is not their main branch to have artists here. But the artists are definitely as well creative people, as we know. And they may also contribute in various other projects.
It's kind of spin-offs that are supported and seen as useful spin-offs for CERN and for the broader vision of what CERN is and should do. But of course, the core business of CERN is what we have seen before. This is building accelerators, building detectors, building the electronics, taking out the data, analyzing the data, make new fantastic discoveries about the inner workings of the universe.
Nice.
So any more comments? Yes, there's one question that just popped up. If there are artists nearby, well, I created a 1 year, 2 semester collaboration with the Art Institute in Geneva. The Geneva Art Institute participate. There are collaborations, but they are not. There's not like this that they here at IDEASquare are as a permanent host for local artists. It's all on projects based, actually.
I have another question. Are there like designated outdoor spaces where you just gather with different people, where artists can gather?
Yes, and I think the most famous and most used one is the restaurant One Terrace. So this is actually as we discussed in further sessions. Restaurant One is the biggest and most important meeting room at CERN, and you have there people coming 24 hours, 7 days a week to sit together and chat, have a coffee. If I want to talk to this guy, I call him up and ask him if we want to have a coffee. That means I would like to talk to you and brainstorm about something. It's not about having a meeting. If we have a specific meeting, it's one thing. But if we have, if we want just to have a discussion on a topic, we have a coffee. Yeah, and that means this is an invitation of a informal exchange of ideas or advancement.
And this is something that works extremely badly via Zoom. I can tell you, because of course since we have this pandemic situation, we are sitting on the screen 24 hours a day almost, nobody sleeps as well. But it's flat land that we are talking about and not a real touch. So being creative, getting inspiration, having brainstorming sessions and getting cool ideas, you need to have a real life experience and then you advance. But whatever you have structured before, whatever you lined up, whatever you have planned, Zoom meetings work very well. So we may well reduce our traveling schedule, but we will never give it up completely because we live from creative exchanges and from coffee at restaurant 1 and other places.
This is also the reason why we wanted to bring you here and have you here, not just to see the site, but also to start the dialogue and the interaction with our community in the place. And this we will have in December.
Yeah, we are ready. But how are we going to keep going between now and then? Is this our final bike tour for June?
This is the final bike tour for now, for the summer, maybe.
Later on
Sorry.
Yeah.
We
just have to think of some ways to kind of keep generating our creativity around it. And
yes, we will. Let's have a brainstorm discussion. So I
yes.
think we will continue. We may continue in the same format. Maybe not to see the same things, of course, but I'd like to emphasize more on people, more on characters like him in exchange. So, but we will definitely continue and to give you at least the Zoom idea of sitting in a restaurant 1 and chatting with various characters.
Mm-hmm. Okay, so maybe we should have a brainstorming session where we bring a coffee and it
Yes.
isn't so early for the Tallahasseans, and we pick some topics and discuss them. Maybe
Yes.
as an artist together.
Absolutely. I mean, I think the next we could round it up. The first sessions now and have a brainstorming sessions. What would a wish list on topics, on venues, so we should have an idea session. What are requested from your side, from the artistic side,
Yeah.
from the artistic team, because now I can also suggest the one or other, because there are plenty other sites you would like to see still, but I also would like to embed a little bit more requests from your side. So what was interesting, what we should emphasize a bit more. Yeah.
Okay. Well, I think I'll send out a questionnaire, send out, some ideas on
Yes.
find out what people want. I know I can see that Mackenzie's got a hand up there. Do you want to add to that, Mackenzie?
I think it's just not going down. It's just permanently up there.
Oh, right. Okay. You permanently
But
have.
I did have one question though. Do all of the ideas have to be useful?
Well, you never know. I mean, let me do. There's a very unique. There's a unique. There's a unique story about what is useful and what not, because we cannot judge now what is useful. There's Edison. You know Edison, who invented electricity, if you like.
Yeah.
Well, no, I mean, no, but the point is, there was you know the story about he was asked by the congressman if this is useful, and he mentioned, well, he cannot answer this question, but he's sure at the end of the day you may tax it. So the politicians can get money out of it, and then it was approved immediately.
Okay, so I have to correct that quote, because Edison, as is typical for Edison, he stole it. Edison was a great inventor, but the physics and the technology was not invented by Edison. But he made it usable with all kinds of device making. But the story goes back to Michael Faraday in the UK, and it was the English prime minister of that time who was asking exactly that question. And it was also then Faraday who came